Basic Statistics on a Spreadsheet is an episode of the Degrees of Freedom project. Videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description. We'll calculate and report the mean and confidence interval using a spreadsheet two different ways. For the first, we'll make minimal use of the spreadsheet's statistical functions and largely duplicate the by-hand calculation. For the second, we'll make liberal use of the spreadsheet's built-in statistical functions. For the purpose of keeping this course free and accessible under Creative Commons licensing, we will be using LibreOffice. However, all of these steps will work equally well on Microsoft Excel and Google Sheets. The first step is to label and enter our data. Start in the second column, which we'll call our measurements column, x sub I. And in the rows below, enter the measured values 5, 7, 4, 6, 4, 6, 5, 7, 5, and 6. The next step is to sum the x sub i's. We'll label the cell sum and use the spreadsheet's built-in sum function. Notice that you can select and enter the entire column. The mean is the sum divided by the count, so we need to count the measurements. We'll label the cell count and use the spreadsheet's built-in count function. The mean is the sum divided by the count, so we'll label the next cell as mean and divide the sum by the count. For the variance, we need the residuals, which are the mean minus the measurements. We have the mean that we want to reference in each calculation, but we want the calculation to refer to the same cell, even if we change the position of the calculation. So we'll need an absolute reference. You can hand enter the dollar signs for absolute reference, but it's quicker to use the keyboard shortcut F4 or Command T on the Mac. On Windows, F4 works as a shortcut as well. The key toggle is the dollar signs. First, both the row and the column, second, just the row, third, just the column, and fourth, none. We now subtract the first measurement. Once we've entered the first cell, we can fill the whole column by simply dragging down from the corner. We actually need the square of the residuals, so we'll make another column labeled E sub I squared and square each of the E sub i's. We could have entered the full formula with the variance squared in the first column and cut down on the number of cells, but this method most closely duplicates the by hand method. We next need the sum of the squared residuals, and since I'm lazy, I'll just copy the name and formula from where we entered it before and paste it here. Since the original formula used relative references with no dollar signs, it will work just fine. The variance is the sum of the squares divided by the count, minus 1. So we'll enter that here. The standard deviation is the square root of the variance as entered here. The estimated standard error is the standard deviation divided by the square root of the count. Next, we'll enter the confidence level, either 0.95 or 95%. Now we have a choice. We can look up in the t-table as we did by hand, or we can use a built-in statistical function. I don't want to hunt down my copy of the table, so I'll use the built-in function, even though it violates the spirit of this first example. We'll enter the t.inv.2t function. It calculates the t-value given the probability, 1 minus the confidence level, and the degrees of freedom, the count minus 1. Finally, we'll calculate the confidence interval, lambda, actually 1/2 of the confidence interval, since our confidence interval is plus or minus lambda, but you know what I meant, by multiplying the t-value by the standard error. We'll place the second method close to the first method. Since I'm lazy, I'll just copy and paste the data. As before, we'll need the count, so I'll use the count function again. For the mean, this time I'll use the average function. And for the standard deviation, I'll use the stdev.s function. The .s stands for sample standard deviation, so it includes the n-1 instead of just n. There isn't a function for the standard error, so I'll have to break down and divide the standard deviation by the square root of the count, so that's why we need it. Again, we'll enter the confidence level, either 0.95 or 95%. We could have also just copied it. We'll enter the t.inf.2t function as before. Oh, that's the other reason why we need the count. And we'll calculate lambda as before. With both sets of calculations done, we'll clean up the spreadsheet a little. We'll select the values of the variance, standard deviation, and standard error, and put a reasonable number of significant figures on them. The icon with the .00 above the error and .0 means reduce the number of decimal places. On the first click, we just get pound signs or hashtags because there are more decimal digits than will fit in the cell. We just keep clicking until we begin to see the actual digits. We'll have to keep going until we have 3 places after the decimal point. We'll repeat the process for t and lambda, and then for the standard deviation and standard error in the short method. And finally, for t and lambda in the short method. Next, we'll bold the answers, mean, confidence level, and lambda for both the long and short method. Finally, we have our x sub i's and our e's and our e squared sub i's. But we don't have any i's. We'll fix that by labeling a column with I, entering the first 2 values, 1 and 2, and then select the 2 and drag down. LibreOffice autocorrects the lowercase I to uppercase I, but we won't worry about that at the moment. The put 2 values and drag a series works with any 2 numbers. So if you need to create an odd series, put 1 and 3, or for an even series, put 2 and 4. Thanks for watching. This video was brought to you by the DOFPro team.